Hi, today I'll be taking two questions from section 3.9. So I've chosen questions number 5 and 6. So we can just get on to it. Question 5 says, a cylindrical tank with a radius of 5 meters is being filled with a water at a rate of 3 cubic meters per minute. How fast is the height of the water rising? So over here, they give us a couple of things that we can take. They've given us the radius, so r is equal to 5 meters. And I've drawn up a diagram here to show that. And they've given us the rate. They've given us the rate of the waters of the volume. So they've given us dV dt, and that equals to 3 cubic meters per minute. And the question asks us how fast is the height of the water rising. So basically they're asking us to find dH dt, so height in respect to time. First we have to take the cylindrical tank and we just find the formula for volume. So for the formula of volume for cylindrical tank is volume is equal to pi r squared times height. So we can take this and we can find dH dt. So they have given us some things that are useful we can plug in, such as we can bring this down to a different formula, to dV dt is equal to, since pi r squared is a constant, we can just leave it as pi r squared. And then we're trying to find the height, but we're trying to find the rate of the height, so we can put in dH dt instead. So over here we already have some we have numbers we can plug it into to derive the answer. So we know that dV dt is equal to 3 cubic meters. You can just put it as 3 is equal to pi, and we know the radius is 5 meters squared, and then we're just trying to find dH dt. So we do have this, and we could just go ahead and simplify this to pi 25 dH dt. I'm going to rearrange that and put in terms of dH dt, so we can just move this to over here, so it becomes 3 divided by pi 25, which equals to dH dt, and that's the answer. So question 6 from section 3.9 says, the radius of the sphere is increasing at a rate of 4 millimeters per second. How fast is the volume increasing when diameter is 80 millimeters? So the first thing, they give us the radius of the sphere is increasing at a rate of 4 millimeters. So we write that down as dr over dt, and that equals to 4 millimeters per second. And the radius of the sphere is half the diameter, and they give us a diameter of 80 millimeters, so the radius will equal to 40 millimeters. So in order to find the rate of variation of volume of the sphere, we derive the expression of the volume with respect to time. But first we have to know the volume, the formula of the volume of the sphere, and that equals to volume is equal to 4/3 pi r cubed. And we have to differentiate that, so I have to take the derivative of that in respect to time. So we do dV dt is equal to 4 divided by 3 pi, bring the 3 down to 3r squared, and then bring it down dr dt. This can be simplified to dV dt 4 times 3 over 3 pi r squared. These two cancel out, and then dr dt. Now we just plug in the given values, or we substitute them in. So we already have the rate. So we have the increasing rate of the volume of the radius. Sorry, we have the rate of the radius, and we're trying to find how fast is the volume increasing. So we could just substitute in those values to dv dt is equal to 4 pi, bring down the radius, 40, so that's times squared, and multiply that by 4, which comes from here, and that equals to 80,425 millimeters cubed per second. And that's the answer.